This presentation presents an introduction to modular construction. So what is modular construction? It is a fully off-site manufacturing process that uses volumetric or 3D units to form complete buildings or major parts of a building. Module sizes are generally limited by transportation to about 4.3 meters wide without an escort and up to 16 meters in length. Modules can often be supported by a separate steel or concrete transfer structure, particularly over open areas. Modules may either be room-sized or partially or fully open-sided to create larger spaces. And the term pod is generally used for non-structural modules placed on a floor. Here we see the installation of a 3.6 meter wide module in a residential building, where two modules create one house. And you see here the modules are lifted by a spreader beam at 8 points along the length of the module. The main application of modular construction is in residential buildings of 4 to 10 stories, with the repetitive use of modular units that occurs in buildings such as student residences and in hotels. Mixed-use buildings and hotels increasingly use a podium level which supports the modules above, and this allows the open space to be created on the ground floor and first floor levels. Educational and medical buildings often use open-sided modules to create larger space by combining 2 or 3 modules together. Terraced houses, particularly in urban locations, are a very good example of the use of modular systems. Specialist services units for hospitals and commercial buildings are also a good example of the use of modular systems. This is a typical modular housing project in which terraced houses of 3 stories and 4 stories are created using modules. And the modules also provide support for balconies, as you can see here. A more common example these days is in the use of modular construction in high-rise buildings, often using a concrete core to provide lateral support, in this case for a 16-story student residence project in Wembley. And on the left hand side you can see the modules being installed, and you can see also the mast climbers used to support the installation of the cladding at higher levels. Modular construction is widely used in schools, primarily because of standardization of module sizes, and also because modules can be installed in a very short period to suit the school holidays. In hospitals, modular construction is primarily used because of the very expensive and specialized equipment that's installed, which can be tested and commissioned off-site. So what are the attributes of modular systems? Well, firstly, they can be assembled to produce load-bearing structures. Module installation rates are very fast, typically 6 to 8 per day. And for larger buildings, an economy of scale in manufacture can be achieved, which reduces the individual cost of the modules. They're also built to very high quality, and services can be installed, particularly in hospitals and other specialized applications. There are various forms of modular construction, the most common form being modules with load-bearing sidewalls, which are generally known as 4-sided modules, particularly for hotels, student residences and other applications. Modules with open sides can be constructed by using corner posts and edge beams to create larger spaces. And it's also possible to produce modules that are very long, combining two rooms with an integral corridor. Modules may be stabilized by concrete cores or supported on steel frames, particularly in high-rise applications. And there's also a big market for specialized services units, bathrooms and stairs. So here we see an example of a four-sided module with load-bearing sidewalls and also with re-entrant corners to provide the attachment points. The walls are generally produced using C-sections that are 100 millimeters deep, and the floor joists and ceiling joists are typically 150 to 200 millimeters deep. Here we see a more precise detail of the junction at a corner of a module, and you can see that a high level of acoustic insulation and fire resistance is provided by the double layer construction of the walls and the floor and ceiling. It's also necessary to provide fire stops, particularly in the cavities around the modules. This is a good example of a very long module produced with an integral corridor, as you can see here, and that combines two rooms with a total of 8 lifting points from above. Open-sided modules are constructed with corner posts, as we see here, square hollow section or rectangular hollow section posts, with long edge beams that are up to 300 millimeters deep. That same system can be designed with partially open-sided modules by installation of intermediate posts. And modules may be placed on a steel or concrete podium structure that provides for more open plan space below the podium level. And obviously the podium has to be designed to support the weight of the modules above. It's also possible to produce modular stairs using a rigid framework as shown here, and also the use of steel stairs supported at both landings and also at half landing. Services modules and plant rooms can be produced as shown here using fairly rigid hollow section members to form the framework of the modules. So what have we learned about modular construction? Well, module size is strongly influenced by the requirements of transportation access and limits on lifting capacity of the crane. Modules are essentially three-dimensional building blocks that require careful control of tolerances in installation on site. Modular rooms may be combined with other components such as corridors, or they may even have integral corridors. Modules may be placed on a podium structure in which beams align with the module walls to support them. Speed of construction and quality of construction are key benefits of modular systems.